Molex conducted this study on 448 gig data transfer. We need to understand what modulation schemes we'll be using, what kind of connector designs we'll be doing, what kind of transmission medium will be used. So all of those requirements needs to be understood well so the industry can start building systems around that to scale to that next generation. So there are two options to increase the bandwidth as we talk about the next generation AI clusters. We can either increase the number of lanes. However, it requires more physical space, higher power consumption. Alternatively, we can keep the same number of lanes, but now run at double the speed. So going from 224 gig to 448 gigabits per second. We selected the modulation schemes based on what we are using today. PAM-4 is a commonly used modulation scheme today at 224 gigabits per second. So the next higher order modulation is PAM-6, and if you continue going PAM-8. There are many challenges when we start running data that fast. The noise budget can be thought of as a sum of various parameters like insertion loss, crosstalk, return loss, or even skew. Each of these parameters takes up a portion of the budget from the total noise budget allowed for any given channel. The role of equalizer is to amplify the signal that has attenuated. Now, if the signal is operating in the linear portion of the insertion loss, then it doesn't have to work as hard. However, if it has to work the nonlinear region where the loss is significantly higher, it tries to boost up the signal, but in doing so, it also inherently increases the noise within the chip and impacts the signal to noise ratio. We need to come up with new materials, new technologies, and enhancements to the manufacturing tolerances and processes. Insights gained from the development of 224G technologies have also provided a foundational understanding that informs our work on 448G solutions.